Tracing code that uses references is one thing, and we'll definitely be spending some time on that. But before we do, I want to talk about probably the most common use case you're going to have for references, at least early on, which is that you want to break your program up into functions, but you want all of the functions to work on some common set of data, and you don't necessarily want to have to pass around copies. So there are a couple of reasons that that might be the case. One of them is, of course, copying stuff can be slow. So in general, we don't tend to worry too much about speed in lower level programming courses, but there does come a point at which we notice speed problems. So if I have a vector of 20 million things and I'm passing it into a function and making a copy, if I call that function often enough, I will notice that there is a speed problem. But maybe we don't care so much about that right now. I mean, obviously, it's about getting the code to work. Well, notice in this course, we do get to a point where speed becomes an issue. But another issue is, of course, what if I would like a function to modify some original piece of data of mine? So I want to keep a vector in main, and I want a function to be able to modify that vector. And we know, of course, this is where we would typically use a pointer or a reference. And what I'm trying to prove with this video is that a reference is the way to go. So I want to run the program the way it's currently written. And we haven't seen the function that we're calling on line 39, but I will show you that it does not work. So the goal of the function on line 39, apparently, is to add 10 to every element of the vector. So I should expect it to be 16, 18, 20, and then 27. But it isn't. When I'm done, I just get 6, 8, 10, 17. So we'll take a look at what we have up here. Up here we've got, well, print vector, which prints the vector. We're going to see this a lot in this course, but nothing looks suspicious there. There's nothing up my sleeve as far as what print vector does. And then my function add 10. So the add 10 function purports to take a vector and add 10 to each of its elements. And if I stare at this, I'll realize that it does actually seem to be doing that. I mean, I'm looping over the vector using indices, and then at each step adding 10 to each element. In fact, I could call print vector to see whether I'm on the right track. And sure enough, this is apparently the call to print vector I just made. It does seem like it adds 10 to every element of the vector. So why isn't it working? Well, if we stare at it for a minute, we'll realize that what's happening is by the second law of assignment statements, when I call the function, I'm passing in a vector, but there's no ampersands in that signature, so I'm passing it in by value. The variable v inside the function is a copy. It is a separate variable. So when I modify it, of course, I'm not modifying the variable in main, and that's why the modification is not reflected at the end of the program. So what do I need to do? Well, I mean, right up front, what I could do is just accept my argument by reference. So we call this, in general, when you pass an argument like this and you're providing the original, you are passing it by reference. So the function is getting the original. When I call the function here, it is getting my original vector v. So we'll try that out to show that that seems to be a step in the right direction. And sure enough, after I run the function, indeed the elements have been updated to add 10 to each of them. So I've passed my vector by reference. Now, one rather creepy observation to make, one place in which the consistent rules that we're used to from C don't seem to apply anymore, is that notice how, in this case, the function is being given access to my original, but I, the person writing main, may not be able to see that. When I call the function, it doesn't look any different than a call to print vector, which is getting a copy. In this case, it's because the function decides whether it accepts the argument by reference or by value. So it takes some amount of control, you could say, away from the programmer writing main. They don't know whether or not their argument is being passed in by reference or value. For example, they could have written the function call thinking it was being taken by value, and then whoever maintains the add 10 function could change that later. Unfortunately, that's a fact of life in C++, giving more control to the function. The reason it turns out is actually, I think, well justified, which is that we'll see as the semester goes on that C++ is convenient for a lot of reasons because of the amount of magic that can happen behind the scenes. When you create a data structure like the designer of the vector type did, or when you write a function like add 10, you need to be given powerful tools to make that function work seamlessly as far as the person using it is concerned. And that includes sometimes being given access to original data. There are are ways to protect against what you pass in being modified if you're worried that a function is taking it by reference when you don't know what it's doing. If you think it's taking it by value and you don't want it to modify it, there are ways to prevent the function from modifying your original. One of them, an easy one, is if you would like the function to get a copy, make a copy and pass in the copy yourself. That way the function will never touch your original because it never knows of it. That's one of a few different options you would have here. Okay, so what I have now is a function that's able to modify my original vector. I want to take this a bit further. So here, when I end up on line 27, the function has the original vector v that was passed in from main. And it's able to modify it by looping over it and performing this modification, so plus equals 10. What I want to show off, of course, is our favorite for each loop instead of the indexing loop. So I can observe that, I know how to loop over every element of my vector because actually I'm doing that up here in print vector. So in print vector, if I want to loop over every element of my vector v, I would write something like for auto x in v. And I could then try some trick like this. And we'll notice that this doesn't work. Unfortunately, it doesn't seem to modify the vector. But what happened? What went wrong? We know that inside the function, it's getting the original vector. The issue is, at each iteration of the for each loop, it's getting a copy of the element. So the variable x, I could also write for int x in v. The variable x that's created at each iteration of this loop is a copy of an element of v. So if I modify x, I'm not modifying the original. So the way around that is, in a for each loop, you can ask, when you iterate over the sequence, you can ask to be given not a copy, but the original element. And you'd write something like this. For each element x in v, where the element is given by reference, which means you are able to modify the element directly inside of the vector. And so we'll try that out. We can see here, I'm now actually I'm modifying the real elements of the vector. And it's also worth just quickly sketching this out. If I have a vector, so here's my vector v, and the vector is a bunch of stuff. So we'll draw a smaller vector for the sake of the example. And there's index 0, 1, 2. If I want, I can write something like int ampersand, we'll call it z, equals v dot at 0. Or actually, okay, first I shouldn't use equals here. I'm not writing C code. Int ampersand z is initialized to v dot at 1. We should know from the previous video that what this is doing is creating a reference, and that means that the variable z is element 1 of the vector. So what I'm actually doing is giving a name to a sub-element of some sequence. I'm actually giving a name to an individual element of my vector. If I want to refer to this, I can refer to it by the name z or by v dot at 1. And that's valid. I am allowed to do that. I'm allowed to make references to anything that I can assign to. And that includes elements of a vector, because we know we could write v dot at I or v dot at 1 equals something. And so what I'm doing here is I'm creating a variable that temporarily refers to a specific element of the vector. When the loop goes around again, it'll refer to a different element, and that allows me to modify the elements. And as you can see, this is a very elegant syntax. I'm now able to go through the elements of the vector and modify them without ever worrying about things like indexing. And references also give me a seamless way to spread my data across the program. I put the same loop here that I would put in main. There's no need for special treatment like there would be with a C-style pointer. So I'll try running that to prove that that works. Sure enough, it does. And then one last note, what I normally do in cases like this is I don't bother with int ampersand, I just use auto ampersand because I know that the compiler can figure out what the element type of the vector is, and we can see that that works as well.